Gas, liquid, and solid samples can be introduced into the ion source through specially designed inlets with controlled flow. A sample must be ionized before the mass spectrometer can analyze it. Two common types of ionization are electron impact and chemical ionization. One method bombards the molecules with electrons. This results in a charged molecule which fragments into a unique pattern which is characteristic of that specific molecule. A filament is the source of electrons. Electrons collide with the molecule to create ions. A repeller is used to help direct ions through a series of focusing lenses in the ion source. Without these components, sample molecules would not be ionized and ions would not reach the mass filter. The mass filter allows selected ions from the ion source to reach the detector. When correctly tuned, it filters and separates ions based on their mass to charge ratio. Only an ion of one mass can pass through the mass filter at a given time. This computer simulation shows three different kinds of ions moving into the quadrupole. Once inside, the ions experience the rapidly oscillating RF voltages. Currently, the mass filter is set to pass the ions shown in white. Ions which are not mass selected, shown in red and blue, become synchronized with the oscillating RF field and are catastrophically accelerated into the rods. There are four classes of mass spectrometers that are used to select and filter these ions. They are time of flight, radio frequency, which includes quadrupole filter and ion trap mass spectrometers, Fourier transform ion cyclotron resonance, or FTMS, and magnetic sector mass spectrometers. Let's concentrate on quadrupole. Quadrupole mass filter may be operated in one of two modes, scan or SIM, selected ion monitoring. In SIM, the mass filter is set to pass one kind of ion. This provides the greatest sensitivity and is used for quantitative applications. It is used when the analyst has prior knowledge of what ions to expect. In scan mode, the mass filter is set to sequentially operate through a range of masses. It has lower sensitivity because most of the ions strike the rods during the scan. For general unknowns, the selected mass may initially be at 100, then 101, then 102, and so on. This is used to generate spectra for interpretation or a library search. A detector is used to collect and count ions or detect their resulting current. Only one mass-to-charge ion is detected at a given time. When the mass-selected ion collides with the detector, the resulting signal can be displayed by the data system. The ion source, mass filter, and detector are in vacuum, so that a collision of a given ion with other sample molecules, air or water, is unlikely. Minimizing collisions ensures that the ions are efficiently mass selected and detected. Common vacuum systems have two kinds of pumps, a high vacuum pump and a rough pump. Initially, the rough pump pulls out most of the air, water, and other gaseous species. The high vacuum pump acts to concentrate the rarefied high vacuum gases, which are subsequently removed by the rough pump, making mass spectral analysis possible. The data system sends information to the mass spectrometer electronics. This determines in part how the inlet, ion source, mass filter, detector, and vacuum system operate. The way the system operates is determined by the hardware design, the tuning procedure, requirements of the chemical analysis, and user preferences.